Okay, let's do this ALEKS problem here, dealing with stoichiometry. We have ammonium chlorate given to us. That is a solid rock of fuel, a very powerful one. And it decomposes into nitrogen and chlorine and oxygen gas plus water vapor. Okay, so we're going to have kind of a big chemical equation here. So we're going to have here ammonium perchlorate is going to then decompose into nitrogen, plus it's going to go into chlorine, plus oxygen, plus water vapor. Okay, so the first thing we have to do is get the chemistry right. I have to make sure that we get a right chemical equation, that it's balanced. And so I usually save oxygens and hydrogens to the end. And so I have 2 nitrogens and 2 chlorines. So if I put a 2 out in front of here, that should get those all balanced. So now I have 2 nitrogens and 2 chlorines. Now for hydrogen, I have 8 hydrogens. So if I put a 4 right here, that should balance out the hydrogens. Now what about the oxygens? So I have 8 oxygens, 2 times 4 here. I have 4 oxygens here. So if I put 2 right here, that should give me the 8. And so let's just double check. Okay, that gives me 8. I have 8. This should be all balanced. If you're not sure, you can check it yourself, but that should be all balanced. Okay, so it says calculate the moles of ammonium perchlorate needed to produce 1.90 moles of water. I guess it'd be kind of a boring one now that we did all that work to get a good chemical equation, but let's just do this. So I am going to produce 1.90 moles of water. Okay, so I have to look at my stoichiometry here, and I can see that I have to calculate ammonium perchlorate. So I can see in here that for every 4 moles of water, I would consume or decompose 2 moles of ammonium chlorate. And so let's go ahead and put that stoichiometry in there. So I have 4 moles of water, or H2O, I should have written, for every 2 moles of ammonium perchlorate. Okay, so it's just a simple stoichiometry problem. That's what's being asked for, is moles of ammonium perchlorate. And so you can do the math from here. So just to make sure you know how I would do it, I would do this is exactly what I would punch into my calculator. 1.90 times 2 divided by 4. And that should get you the right answer. So in these problems, understand the stoichiometry. And we get that stoichiometry by creating a balanced chemical equation. And then we use those stoichiometry coefficients out here in front to answer various questions. Okay, that's how I would do this particular problem.